In this exercise, we're going to look at a simulation of radioactive decay. Now, if we have a radioactive atom or a group of radioactive atoms, the probability that any one atom will undergo a decay in a period of time, say a second, is given by the decay constant lambda. So the total number of decays in a second in a quantity of material which has a lot of atoms in it is just the decay constant times the number of atoms. And that gives us a decay rate or an activity. The R is simply the number of decays per second in a sample. And we measure that in becquerels. 1 becquerel is just 1 decay per second. And of course, when we're dealing with atoms, N can be a very large number, 10 to the 10, 10 to the 20 or so atoms. We're going to look at an analogue of radioactive decay. So rather than work with radioactive materials and difficult to use machines, we are going to use an analogue which consists simply of dyes. And the idea is, instead of measuring time in seconds, we'll measure time in throws. And to our beginning time, t equals 0, we'll have 96 dyes. Then we'll simply throw all the dyes, and they're all finely spread out like that. We have our 96 dyes. And what we'll do is we'll pick a particular number, and it suggests the number 6 in the laboratory notes to say anything that turns up a 6, that is something that is decayed. So in any one time interval, we expect 1/6 of the atoms, or in this case dyes, to decay. And so we'll simply pick out any dye showing a 6. So we now have fewer dyes left. And of course, as time goes by, these dyes will continue to decay. So ultimately, the ones that have come up 6 have, we will say, decayed. So after throw number 1, we simply need to count the number of dyes that we have left, write that down, and that's the number that we're dealing with after one time increment. You then simply need to gather all the dyes up again, and we'll simply throw them again. And again, we simply need to pick out all the ones that have turned up as a 6. So after 2 throws, again, we need to count the number of dyes that are left and record that number. We need to do this at least 20 times or until we run out of dyes. And that allows us to accumulate some data, and we can begin to draw a graph of number of dyes versus time, or in this case, number of dyes versus t throws, and see how that decreases. It should be an exponential decay. To get some sort of smoothing or averaging out of this data, we'll get you to get 4 sets of data, starting with 96 dyes and then repeatedly throwing them until you either run out of dyes or hit 20 throws, and then average those values, and we'll get some data in which we can analyse the rate of decay of these analogues of radioactive materials.